Hello students, in this lecture we are going to learn what is the difference between the strength and concentration of an acid. We will also learn that how we can measure the strength of an acid. So let us begin with our lesson. Strength versus concentration. Now these two terms, many a times the people get confused that what is the meaning of the strength of an acid or concentration of an acid. So let us discuss this. When we describe acids and bases, strength and concentration do not mean the same thing. Strength refers to the ability of an acid and base to dissociate in a solution. For example, if you have got 100 ml of water and you have to dissolve 10 molecules of HCl in it. And if you put these 10 molecules of HCl in water, all the 10 molecules of HCl will break down, will split up to form 10 hydrogen ion and 10 chloride ion. So in this case, we can say that all the molecules of HCl have dissociated completely. This property provides strength to the acid. There are few acids which do not dissociate completely. For example, if you take 100 ml of water and you have 10 molecules of acetic acid, when you put these 10 molecules of acetic acid in water, all the 10 molecules of acetic acid do not split up, do not dissociate, which means only few of them will dissociate, maybe 4 to 5 molecules will dissociate, and rest of the molecules will remain as it is. So here we have got only 4 to 5 H plus ions. So in this case where there is partial ionization, such type of acids are called as weak acids. Now when we talk about concentration, here it doesn't depend upon the acid, but it depends upon that how much amount of water is being added to acid. Let us see this. When we talk about strength, it measures the pH and it tells us that how much strong an acid or a base is. Dissociation refers to the ability of an ionic compound to break apart into ions. Now the concentration refers to the amount of acids and base dissolved in a solution. For example, as I have given you that we have taken 100 ml of water, but now if I dissolve 50 ml of acid in 100 ml of water, then we will consider it as a concentrated solution of acid. But if I dissolve only 10 ml of acid in 100 ml of water, then it will be considered as dilute acid. So in this case, the concentration of hydrogen ion doesn't depend upon the amount of acid, but it depends upon that how much amount of water is present. There is more amount of water in a dilute solution, whereas in concentrated solution, the percentage of acid will be high. Now it also changes the pH of solution as the number of ions change by increasing the volume of water. Just because you add water to dilute it, it's still going to have the same amount of hydrogen ions. Means if suppose in 100 ml of water there are 50 hydrogen ions. Now if you add more 100 ml of water in that, still the number of hydrogen ions will remain 50. So that is called as concentration of ion. Strong and weak acids and base. When a strong acid base dissolves in water, nearly all of the acids bases molecule will dissociate into ion. Now this is what I have explained, where you can see in this diagram there are many H plus ions you can see, because this is a strong acid. The greater the ability to dissociate, the more potential the acid or a base has for being dangerous, because there are more ions available to react. So they will be more strong and more vigorous. When a weak acid or base dissolve in water, only a small fraction of the acid base molecules dissociate, which is called as partially dissociation. With less ions in solution, there is less potential for danger, because there are less ions available to react. So the reaction will not be very vigorous. Here you can compare the number of H plus ions in this strong acid and in weak acid. In the acetic acid, there are more number of acetic acid molecules are present in their original form, whereas only 2 molecules of acetic acid have broken down into ions. So there are only 2 hydrogen ions, and in this case there are many hydrogen ions. So we will consider this complete dissociation as strong acids and partial dissociation as weak acid. The same thing happens with base also. When we talk about sodium hydroxide, which is a strong base, it dissociates completely in the water. Whereas if we talk about ammonium hydroxide, which is a weak base, it does not dissociate completely, and hence it is considered as weak base. Now, how to measure the strength of acid or base? We have discussed that different type of solutions show different strength. Some of them can be highly strong acid or base, and some of them can be very weak acids or base, and there may be some which will be in the moderate level. To find out the strength of acids and base, we use pH scale. Now pH scale is a scale which is used to consider or to find out the number of concentration of hydrogen and hydroxide ions. The pH of solution varies from 0 to 14. Solutions having a value of pH ranging 0 to 7 on a pH scale are termed as acidic. Solutions having value of pH ranging 7 to 14 on pH scale are known as basic. Solutions having the value of pH equal to 7 on pH scale are known as neutral. Now let us see over here in this diagram, you can see that the pH level is given from 0 to 14. As we saw that 7 number on the pH scale represents neutral. When you move from 7 towards 0, the acidity of the substance increases, which means the substance start turning from neutral to acidic in nature. And when we go below the 7, the substances show that they are turning or increasing their alkalinity. So here in this pH paper, from 0 to 7, this value shows the acidic nature, and from 7 to 14, this value shows the basic nature. Now we can see over here some of the common examples of the different pH values are given. Sulfuric acid or any battery acid represents the value of 0. Stomach acid, that is HCl, represents the value of 1. Lemon juice, vinegar, they will come in the category of the moderately strong acids. that is between 2 to 3. The weaker acids will be tomatoes, coffee. Yes, coffee, even though it is bitter in taste, but it is acidic in nature. Then comes the pure rain. It shows the pH value around 6. And the distilled water will be showing you the value of neutral, that is 7. When we go below 7, that is seawater or baking soda, these are some alkaline mixtures or alkaline salts where pH belongs to between 8 to 9. Below that, it is milk of magnesia, which is antacid. Its pH value is around 10 to 11. Household ammonia, for cleaning purposes we use it. It has the value between 11 to 12. Household bleach is having value from 12 to 13. And the most strong base, that is sodium hydroxide, lies at the end of the pH scale with the pH value 14. Now, when we have known the pH value, how do we identify the strength? For that, we use universal indicator. We have also discussed about indicators previously, who were the chemicals which was responsible only to change the color and tell us whether the substance is acidic in nature or basic in nature. But universal indicator help us to know the nature of the liquid. With that, it also tells us the strength of the liquid, which means it also tells us whether the given substance is highly acidic or highly basic, or a weak acid or a weak base. A universal indicator is an indicator made of a solution of several compounds that exhibits several smooth color changes over a wide range of pH values to indicate the acidity and the alkalinity of solutions. You can see over here the common universal indicator which we use in the lab is universal indicator in the form of pH paper. This is pH paper which is initially yellow in color, but it changes its color depending upon the solution you are putting it. Similarly, this is universal indicator in a liquid form. This also gives different colors in the different strength of the substances. This is the range of the color which is shown by the pH paper or universal indicator. When the acid is very strong, the pH paper will turn red. And when the substance is highly alkaline, it will turn dark blue or violet. And when it is moderately acid, then it will change from orange to yellow, and from yellow to green, and then from green to blue, and then to violet. So these are the different shades of the color which are helpful to identify the strength of the acids and also bases. Now, how the strength changes, for that we have to understand this. pH value is inversely proportional to the concentration of hydrogen ion. Now here in this diagram, you can see that neutral is at the value of 7. So from 7, if we are moving towards 0, you can see the concentration of hydrogen ion is continuously increasing. Here the concentration of hydrogen ion is very less, whereas when we move towards 0, the concentration of hydrogen ion has increased. Which means when the concentration of hydrogen ion will be maximum, the pH value will be 0. Now here, when we move from 7 to 0, similarly, when the hydrogen ion concentration is increasing, with the same rate, the concentration of hydroxide ion is decreasing. That is why the acidic nature increases when we move from 7 to 0, which is due to increase in the H plus ion concentration. Now see what happens when we are moving from 7 towards 14. Now here you can see that when we are moving from 7 to 14, the hydrogen ion concentration is repeatedly decreasing, whereas the concentration of hydroxide ion is increasing. Now this happens because there is decrease in the hydrogen ion concentration and increase in the hydroxide ion. From 7 to 14, the basic nature increases, and we know that the concentration of ion is related to the pH value. So least will be the concentration of hydrogen ion, maximum will be the pH value. Because here the hydrogen ion concentration is least, the pH value is highest. So in this discussion, I hope you are clear to understand that the strength of acids and bases depends on the number of H plus ions and OH minus ions produced. Acids furnish more number of H plus ions are known to be the strong acids and vice versa. The degree of ionization of acids and bases differ from different acids and bases, which means its value will be depending upon that which type of acids we have taken. If it is a strong acid, their ionization will be maximum, and because of that their strength will be high. The degree of ionization of acids and bases differ for different acids and bases. It helps in the determination of the strength of acids and bases. Acidic solutions. How the concentration changes. In the acidic solution, hydronium ion concentration, when we talk about hydrogen ion concentration, it is similar to the hydronium ion concentration because the acidic nature can be considered only when hydrogen combines with water molecule. So, in the acidic solutions, the hydronium ion concentration is higher than the hydroxide ion. For neutral solution, hydronium ion concentration and hydroxide ion concentration will be same. And for basic solutions, hydronium ion concentration will be less than the hydroxide ion concentration. So this is how the change or increase and decrease in the level of hydrogen ion concentration, the pH value of a substance also changes. Now I hope this much concept is clear with you. And now we will be discussing the next topic in the next lesson. Thank you.